All right, we're solving radical equations. We're taking it a step past what we did before, so I'm just going to show again what to do. Solve each equation. It does say remember to check for extraneous solutions. Do you remember what that means? Are you supposed to know? We have discussed it, so let's talk about it again. Extraneous solutions mean solutions that do not work. Don't you remember checking for some? So they're solutions that you get that don't work. What do you mean? I mean by don't work. If you plug it back in, right, Scott? If you plug it back in, they don't satisfy the original equation, is the way you kind of say it if you want to be mathy. All right, square both sides. If I square the left side, I would get -1 minus 2x. Squaring the right gives me x squared. Need to set this to 0. So I'm going to add 2x and add 1. Then I'm going to factor. I get 1 factor because that's a perfect square trinomial. The perfect square x plus 1 quantity squared is the factored form. And then you set that factor to 0, and you solve, and you get -1. All right, now you go and check into the original equation if -1 works. Well, that would have something under there equals -1. Is anything that comes out of here going to give you a negative result? Nothing. That has no solution. The only solution we got does not work. Okay, number 2. Square both sides. We have x squared equals -10 plus 7x then. I'm going to subtract 7x and add 10 to get it set to 0. Then I factor this, x minus 5 times x minus 2. That gives me a solution of x is, oops, it was x minus 5. I probably don't really need to keep on writing them set to 0, do I? X minus 5 equals 0 gives you x is 5. X minus 2 equals 0 gives you x is 2. Now, if they're that basic in the x minus a form, I can just say what the answer is. I'll try to go through that point next. Now, are 5 and 2 good solutions? Well, they're both positive, so I'm thinking I might have a good chance of getting 2 answers this time, but I better check. Put 5 in over here and 5 in over here. -10 plus 35. I'm realizing that you probably would do some of this in your head or on your calculator. So if you did -10 plus 35, you get 25. 25 to the 1/2. That means the square root of 25 is 5. So I know 5 works. If I put in 2, that would be 14. -10 plus 14 is 4. So yeah, that's going to work out fine. So I did get 2 solutions on this one. So far, we found that some of these have no solution, some have 2 solutions, and then others may have 1. Okay, so it's possible to just have 1. So there's 3 possible ways of getting answers to these. 3 scenarios. Squaring both sides on the next one, number 3, gives you 30 minus m equals m squared. I'm going to set it to 0 by adding m to both sides and subtracting 30. I'm going to factor it, m minus 6 times m plus 5. I get m is 6 for one solution and -5 for the other. Which one do you think might be the one that might be scariest according to this worksheet? Or what's on the back here? Oh, thanks, Scott. I got opposite signs on these. I went too fast and I said add, I don't know what I said. I thought I said add m and subtract 30, and then I didn't write add m. That's my fault. So what it does is changes the sign of both of those answers. Thanks for spotting that before I continued. Okay, -6 and 5 then are my solutions, right? Okay, now, -6, is that going to work? Because it would say that you've got, let's see, -6 would give you plus 36 in there. That would be the square root of 36 equals -6. Okay, now I had some students question this second hour, and I'm thinking maybe I should explain what I had. A really good student of mine asked me a question, and I thought if she thought that, maybe I better clarify. This does not have, taking the square root of something does not give you two answers. It gives you just one. When you take the square root of a number, it just means the principal root, which is +6. Okay, so 6 doesn't equal -6, so the -6 is no good for a solution. What kids get confused with is problems that have an x squared in them. If that were the problem, this problem has two solutions. Okay, when you take the square root of both sides to solve a problem with an x squared in it, then you get plus or minus the square root of 36. This answer would be plus or minus 6. But this answer is not. There isn't an x squared in the original problem. Okay? So when you actually just take the square root of something, it is the positive root. So a principal root. All right? So I'm hoping that might have clarified for somebody in here what the difference is between this getting two answers and this is only one. Okay, the answer to this is just 6. Okay, now put in 5. Is that okay? Yeah, that'd be 25. 5. A square root of 25 is 5. All right, that one checks out. So we only have one solution. So there's our three scenarios. No solution, two solutions, or one. All right, this one, you got a radical on both sides. So we're going to square both sides, which we have to do to one side, we have to do it to the other. Okay, then I get add 2n to both sides and add 3 to both sides. Divide by 3 and we get n is 4. And then I'm going to plug in 4, so that's going to give me the square root of 1, and on the other side the square root of 1, so we're good. 4 is a solution. Okay, can I move? Okay, number 5. 1/2 exponent is the same as the square root. Square both sides. You get 4x minus 1 is equal to 3x. Subtract 3x from both sides and add 1, you get x is 1. Plug back in 1, you'd get the square root of 3 equals the square root of 3, and that's okay. These should go pretty quick. Square both sides. 3x minus 1 equals 2x. I'm going to subtract 2x and add 1 to both sides, and I get x is 1 again. Plug in 1 would work. We okay with these? I kind of went really fast through them because they're kind of boring problems, actually. All right, then. 7, we got 3p equals 5 minus 2p. Thinking adding 2p, we're going to get 1 again. And that's okay. Doesn't mean the answer of 1 is always okay. It was kind of ironic. All three of those came out to be 1. A computer generated, a program generated the question. Careful. Number 8. You will see this again, and some of you will forget what I said about it. When you square the k minus 10, you better be careful. That gives us 40 minus 4k on the left. What does it give us on the right? Oh. See, it's just, dang. I need to get someone to clean this computer up or do something, because they've already tried once and it's it's so slow it wants to close programs on me that I want to use. Make me mad. All right. You guys, what'd you say now again, please? K squared plus 100. That's what I wanted to. Ugh. I was knowing I was going to hear that from someone. Does this FOIL out to give you K squared minus 100? Do you ever just go in and square both of those things? It means this, guys. You know that. I've told you over and over again. Be careful when you have a quantity of two terms where with a difference or a sum squared. There's three terms. It's a trinomial. I got negative 10K twice. It's minus 20K plus 100. Yes. Forgot to write it when I wrote the K. K squared minus 20K plus 100. All right, let me remind you again. I'd like you to learn this. It would speed things up for you, so you don't have to go writing this. When you do a binomial squared, K times K squared. K times negative 10 is negative 10. Double it is minus 20K. That helps you understand completing the square, too. 10 times 10 is 100. Why do we double a 10K? Because you get two of them. That's why we cut the value here in half when we want to complete the square. All right, let's finish solving it now that I yelled at you about it, basically. Sorry. K squared, we're going to add 4K, will give us minus 16K. We're going to subtract 40, which gives us plus 60. And there we go. I had to get a bright color because of this background. And then 60 has factors of 6 and 10 that add up to 16. They're both B minus, and then we get two solutions of 6 and 10. We finally need to check if both of the solutions work within the confines of the original equation. And one of them will not. If you put 6 in on the right side, 6 minus 10 is negative 4. If you put in 6 in the left side, the square root of 40 minus 16 would be this, was that 40 minus, no, 24 would be 16. The square root of 16 is not negative 4, it's positive 4. So the 6 is no good. But 10, if you put 10 in, you get 0, so it's fine. The only solution that works is 10. Okay, tell me if we still need this page. All right, next set of examples, 9 and 10 are a little bit on the complicated side. Number 9 is not ready to go. What do we have to do first? Add M. Why? How would I word it? How have I worded it when we wanted to do things that we wanted to get a loan? I said we would isolate the radical or isolate the absolute value. All right, so we want to isolate this. This is the square root. It's a radical. Square root of 1/2 means the square root of that thing. Okay, so adding M is the correct thing to do. You're correct there, Haley. All right, so adding M, I'm going to put it in front, M minus 6. All right, now I can square both sides. And now I need to remember that when I square the left, I just drop things. They're inverse operations, M minus 4. And then if I square the right-hand side, I do not get M squared minus 36. I get M squared minus 12x, or M, plus 36. All right, so that's 0. I get M squared minus 13M. And I get 40. Did I do that right? Yeah. The factors of 40 that will add up to 13 are 8 and 5. Plus 2, and it's both minus 8 and minus 5. So I get solutions of 8 and 5. If I substitute 8 back in, 8 minus 4, 4 to the 1/2 is the square root of 4, which is 2. 2 minus 8 will equal -6. So that one checks out. If I put 5 back in, 5 minus 4 will give me 1. Then I'd have -5 equals -6. Wait. 5 minus 4, that'd be the square root of 1 minus 5 equals -6. No, that's not going to work. It's going to give me -4. These aren't equal. So we only had one solution. All right, and one more of these. Square both sides. K squared minus 6k plus 9 equals 2k minus 3. Subtract 2k to get 8k and add 3 to get 12. So set it to 0. And then this factors to k minus 6 times k minus 2. So I get positive 6 and positive 2. But one of them doesn't work. 6 does, 2 does not. Because if I put in 2, 2 minus 3 is going to be -1, and I'll never get that out of a 2 times 2 minus 3. So this would be -1, and that's not going to equal the square root of 1, which is 1. Okay? I believe that's the end of our examples on notes. Now, on the other side, I'm going to show you something else. I'm going to pause for a moment. Okay, we need to have a graphing calculator to do this part. So we're going to use that to solve the equation. And you might think, well, what do you mean? What? Well, how are you going to type in that? That's why I got to tell you, so you know what to type in. All right, under Y1, put the left side. And under Y2, put in N. Okay, now, before we do that, no, that's my directions. You don't have to write it down if you don't want, but it's your notes. If you want to write it down, that's fine. Well, before we get into looking at this, because sometimes the graphs don't show up very well, I want you to remember that you will be responsible on the next quiz for solving it without the graphing calculator, okay? You will not be able to just write the answer down. You have to show the algebra, okay? So let's do this first and see what we expect our solution to be, and then the graph is going to make a little bit more sense. If you remember the graphs of the square root of x, the graph of the square root of x looked like this. The square root of 0 is 0. Square root of 1 was 1. Square root of 1, 2, 3, 4 was 2. You remember the graph of the square roots was like that? That's the parent graph, because we graphed those before. You're actually supposed to know that. And then if you had y equals x, it's going to be a line that cuts the first and third quadrants in half. So my suspicion is it's going to cross right here at 1, 1. All right, so how can I solve that algebraically? Well, I square both sides, and I would get 12 minus n equals n squared. I would set it to 0, n squared. Add n, subtract 12. I would factor, and I don't know. I guessed on what the answer was. It might even not be right. How does that factor? 4 and 3. So plus 4 and minus 3. Okay, so I'm thinking maybe I was jumping the gun on the answer. So it's not 1. 1, 1 would be a good one, though. Oh, this one isn't the parent graph. Do you get what I'm saying now? This one is shifted. It's going to be a different solution. So we're getting -4 and 3. All right, let's see if our graph of this one hits -4 or 3. If you substituted one of those in, it wouldn't work. Which one wasn't going to work? Okay, the -4. All right, so let's see why. Oh, I thought I fixed this. What? I know, but I had a problem. I reset it. Okay, I'm just clearing it so I can start over because I froze it earlier today. All right, second square root was at 12 minus x. Okay, in y2, I'm going to put in, what was it, x, right? And then I'm going to hit zoom 6, so everybody's looks the same. -12 minus n. Hey, that thing turned it around. That made the graph go this way. The square root graph, instead of going like this, it went like that because it had a minus x in it. And then see that crossing right there? Yes. Yours isn't doing it either? Try hitting, you know what? I don't know what else to do. Okay, let's sketch what the graph looked like. It's no big deal. I'm just asking you to do this. Jeez. Went like that, and then there was a line that went through it, and it, oopsie. And this point was 3, 3. X equals y. It has to be the same. It has to be 3, 3. Okay. What? Because x equals y is one of our equations. 3 was the value. You get 3 equals 3. 3, 3. Okay, square both sides. On number 2, let's see what we expect the solution to be. -24 plus 10x equals x squared. Set to 0. X squared minus 10x plus 24. X minus 6, x minus 4. You get x is 6 and x is 4. So it looks like that one might cross in 2 places because those 2 solutions work in my equation here. This one has 2 solutions. So let's see if we can try looking at it on the grapher. Okay, clear. Second, x squared -24. Ooh. Okay. Plus 10x line 2 x zoom 6 looks like it hits it in 2 places. 4 and 6 seem very reasonable. You see how this is shifted over to the right? That's because the domain is limited on the square root functions because the part under the radical has to stay positive. Okay, so that line does intersect it twice. Okay, let's try another. Oh, I forgot to sketch that one. Yeah, if you sketch it, it's not that big a deal. It's just another one where this goes through here and then that just hit twice. That's all I'm thinking. No. Yes. Yes, it only had 1 solution. It was just 3. No, the -4 does not work, and we've got algebraic proof. Guys, can you quit screwing around? Thank you. That would be the 4, and this would be the 6. So it would have been... Okay, anyway. All right. Try to yell at me again to close the program. Screwed up computer. All right. Squaring both sides gives you 65 minus 7k equals k squared minus 22k plus 121. If you set it to 0, adding 7k would give you negative 15k. And then subtracting 65 from 121, is that 56? K minus 8, k minus 7. Okay, so we're expecting 8 and 7, but I don't know if both of those work. Do either of them work? Let's see. If you put in 8, you're going to get a negative over here, right? If you put in 7, you're going to get a negative. So these don't even cross. So we should get no solution. Okay, and let's check in the grapher. The lines don't intersect. So you probably can just visually see it. Guide mail. Forgot to unplug my... I played A10N earlier. Okay, what was it? The square root of what, please? Minus what? Okay, and then the other line? K minus 1, x minus 1? 11, minus 11, thank you. So, see that line? It misses it. That's, don't ever hit. That has a x-intercept, a y-intercept negative 10 and a slope 1, and it never hits that graph because it's out of its domain. Okay? So for a sketch on that one, you just got one line that goes that way, and the other piece goes like that, so they just don't hit. All right, you would have to subtract 2 to solve the next one before you even squared both sides. You would square both sides, subtract 3, okay, and add 2, that's a k. This factors to k minus 6 times k minus 1. So we might have a solution of 6 and 1. And those might both work. Okay, so I will look at the paper. I think I better put the k minus 2 in here and not try to write it. Well, I guess I could put it like, let me put it in exactly like it looks on the square root of 3x minus 2. And then I got to get out of the radical, so I have to arrow out, and then I can hit the plus 2. Is the calculator working at all? It is now? Oh, awesome. Oh, looks like only one of the solutions works. And that's, yep, 1, 2, 3, 4, 5, 6. So you can verify on there. And I'll make a sketch of that, yes. Yes, it shows the 1 won't work. Oh, really? If you put in k minus 2 and then that one? Interesting. Let me try plugging in that 1. If I put 1 in here, That would be the square root of 3 times 1 would be 3 minus 2. And then I'd get square root of 1 plus 2. That's 3. 1 does not equal 3. So it shouldn't work. So let me check why it works. You said this works though? All right, if I put 1 in here, I get 1 minus 2. No, it doesn't. That'd be, no. Negative 1 does not equal 1. So let me come see what's going on. Hold on. Okay, we're just, I don't know why this is on the screen, but anyway, we are just going to practice a little bit more of these on our own in class. So assignment is worksheet 23 and 25. 23 is on the quadratic formula and its puzzles, and 25 is on what we went over today. Monday, we will do the quiz preview, and we will have a quiz 5-4 to 5-7 on Tuesday.